Isaac Newton, the man whom had an apple fall on his head and decided to call it gravity. He is also the, shall I say, founding father of Newton's laws, hence the name Isaac Newton. You've probably heard of the laws at least once or twice, if not more. After all, they do apply to our everyday life. They're practically the rules of motion if you think about it. They're also the foundations of basic movement. There are 3 laws, and all of these laws work together in a system. A system is a group of things working together, whether it be beneficial or not. Okay. Now we'll get into what the laws actually are and what they mean, and probably a few examples of what they do. Okay, so we have the first law. The first law states, an object at rest stays at rest, and an object in motion stays in motion with the same speed in the same direction, unless acted upon by an unbalanced force. That's a lot to take in, but it's easy to break down. So the first part says an object in motion stays in motion. That's the second part. An object at rest stays at rest is the first part. That practically means if, a ball. We have a ball. If that ball is not moving, that ball will not move until a force, external force, is acted upon it. And only then will it move. Now, the second part states, an object in motion stays in motion with the same speed and the same direction, unless acted upon by an unbalanced force. Now, the unbalanced force can also be the net force, and that will be stated in the second law. But for the first law, it means if something like a car is going along, it will keep in that same direction and speed unless acted upon by, another car comes and hits it. Then that's called collision. If that car hits it, both cars will probably stop. Okay, now that we got the basics of the first law out of the way, we can move on to a little bit of a history about it. Not much, but just a little bit. So this idea was a belief of Galileo and Aristotle. Both believed where motion is, there must be an external force acting on it. And this kind of plays into inertia. And in case you don't know what inertia is, it's a matter in a state of rush or movement until acted upon by an external force. You've been hearing the word external force a lot, and to just give a better meaning of what it is, it's in the name. It's just a force acting on an object that is outside of the object. It can make it go or it can make it stop. And that's practically just what it is. Okay, now we can move on to the second law. And the second law states the acceleration of an object is dependent upon 2 variables, the net force acting upon the object and the mass of the object, or force equals mass times acceleration. So, like before, I mentioned net force, and in case you're unaware of net force, it's just a total force acting upon an object, and that and mass play an important role in acceleration. And the mass, it may not seem like it would, but it plays a major role. I mean, if you have a heavier object, it's going to take more force for it to go, right? For it to make it excel. And that's the second law, and that's how it plays in. Now, the most famous law, or the most well-known law most people have heard of, is the third law. And this third law states, for every action, there is an equal and opposite reaction. It's basically in the name, meaning if you have an action, and that action could be anything. It could be anything to do, from moving your hand, or just blowing a gust, or blowing something out of your mouth, or a gust of wind. There's a reaction for that, whether it's equal and opposite. And for example, we have, let's say, a gust of wind, and that wind would be the action, right? That gust. And equal and opposite reaction would be something moving from that or something stopping. Like a car. If there's a gust of wind pushing against that car, maybe that car's going to stop because they're canceling each other out. Or maybe if that wind blew, it's going to push something like a ball. That ball is light, and the wind is forceful enough to push that ball. That's what the third law really means. For every action, there's an equal and opposite reaction.